Okay, let's now take a look at the electrostatic force of attraction. And Coulomb's law states that the electrostatic force between two charges is proportional to the product of the charges, inversely proportional to the square of their separation. And its direction is along the line joining the two charges. Based on that, we can come up with the electrostatic force of attraction and the formula. Epsilon naught is the permittivity of the medium in which the electrostatic force is acting through. And in this case, the value that's quoted, the value that's provided in the data booklet is the permittivity of vacuum. And that value is 8.85 times 10 to the power minus 12. So the epsilon naught given in the data booklet is the permittivity of vacuum. Okay, so from the electrostatic force of attraction, we could now derive the electric field strength. So the electric field strength provided by capital letter Q is defined as the electrostatic force acting per unit positive charge. So in this case, we will remove away the Q. One of the ways whereby you can faster do your mathematical calculations is to know that 1 divided by 4 pi epsilon naught is 9 times 10 to the power 9. So if you do that, so with that as a proportionality constant, in terms of calculations, you can do faster. We now take a look at the next set of formula, the electric potential. Electric potential is defined as the work done by an external agent per unit positive charge in bringing the charge from infinity to that point constant without acceleration. So it's important to emphasize on two things. One, electric potential is the work done by an external agent. The next part is to mention that the work done is to bring the charge from infinity to the point constant and without acceleration. So with that, we know that the force and the distance traveled is in opposite direction. So we put a minus there. So from there, we can again derive the expression we can then derive to arrive at the expression that electric potential energy is QQ over 4 pi epsilon naught R. And with that, we can then define the electric potential is the work done in bringing a unit positive charge from infinity to the point constant. So in the case, the expression will only be left with Q divided by 4 pi epsilon naught R. Let's take a look at the electric field line when Q is positive charge. In this case, you will come up in this. You will move, in this case, the electric field line will move away from capital letter Q. And we have 2 points to consider, point A and point B. So at point A, the electric field strength should be higher than point B. At point A, the magnitude of the electric field strength is higher than point B. And the direction is in the direction of the field line. Similarly, if you look at the potential, it is still the same. So potential is equal to, potential is inversely proportional to R. So as R increases, your VB will also drop as well. So VA is still higher than VB. Let's see what happens now when Q becomes negatively charged. When it becomes negatively charged, the electric field line is going in this direction. So therefore, because of that, the electrostatic force of attraction is also towards Q rather than away from Q earlier. And when you look at the electric field strength at point A and point B, you will find that the magnitude of the electric field strength at A is still higher than that of B because point A is nearer to the charge Q. However, when you look at the electric potential by having Q as negative and R being smaller, this will be a larger negative value. So for example, like minus 10 volt, then this could be minus 5 volt. So in this case, minus 5 volt as a potential is higher than the minus 10 volt. But we can conclude that in the direction of the electric field line, the potential decreases, regardless whether it's positive or it's negative. Because if it's negative, then you're still going from a higher potential at point B towards point A. And bear in mind that the electric field line is towards Q when Q is negative. However, when you now look at electric field strength, you will find that in the direction of the electric field lines, the magnitude of the electric field strength decreases when the charge is positive. When the charge is negative, in the direction of the electric field line, the magnitude of the electric field strength increases.